Welcome to the fourth episode of our podcast series From Lab to Life. And what a way to make a strong comeback after the summer break by welcoming a truly special guest, someone most of you already know and admire, Professor Andreas Strohmayer from the University of Stuttgart and chairman of the EASN Association. As we know, Andreas has made remarkable contributions to European aviation, and today we will explore his insights, experience, and visions for the future. Andreas, welcome. It's really an honor to have you with us.
Hey Nikki, thank you for having me at this Concerto podcast series. I'm really looking forward to our discussion.
Andreas, we know your outstanding career and long-standing commitment in aviation. Could you please tell us more about your journey at the Institute of Aircraft Design in Stuttgart and how your team's pioneering work in aviation?
I'm heading the Institute of Aircraft Design at the University of Stuttgart, where we have almost 30 years of experience with electric flight, starting with the Icari 2 solar-powered motor glider in 1996. And in 2011, we designed and built the eGenius, initially battery electric, then in 2016 converted with a range extender, and again in 2022 with a full hybrid electric powertrain. We operate our electric aircraft under permit to fly with the German authority, and also the eGenius has a 400-volt electric system, and hence we lead the proof of concept for high voltage electric distribution in the Concerto project.
That's really impressive. Almost 3 decades of pushing the boundaries of electric flight. So, considering this notable path that spans from your early days in aerospace, could you share how your journey began and what led you to take on such a series of ambitious roles?
I came to aerospace from the language side actually, so I always liked different cultures, foreign languages, and I realized that aerospace is fully international, with customers and partners from all over the world, also a global supply chain, and that's where I wanted to be part of. So, having studied aerospace, my doctoral thesis was in the field of conceptual aircraft design. And actually just 2 months after my PhD defense, I found myself heading an aircraft manufacturer where we were designing, building and maintaining a global fleet of all composite aircraft, gliders, general aviation aircraft and military training aircraft. And then we stepped up with this company up to an all carbon fiber business jet, which unfortunately did not see certification as we did not survive the financial crisis in 2008.
Andreas, it's very brave of you to openly share a failure from your journey. Most people tend to highlight only their successes, forgetting that success is often built on a whole series of failures and lessons learned along the way. So, from leading global supply chains and overcoming disappointments and both political and economical challenges to finally taking on the professorship in Stuttgart. Could you please share with us how you managed that transition, how you expanded your department's involvement in European projects, and the role you have played in shaping European research and innovation?
I then went to a startup in France for some years as program director for a 19-seat commuter aircraft. But this time, way before certification, the political dimension stopped us due to the election of a new French president. About this time, I got the offer to apply for a professorship in aircraft design in Stuttgart, which was very attractive due to the activities in electric flight, together with, and that's unusual for universities, with piloted as well as unmanned test aircraft. So when I came to Stuttgart, my department had only limited involvement in European projects, so I had to set out to increase visibility and build a European network. And finally, in my function as chairman of the European Aerospace Science Network, I got involved in the first discussions to define the strategic research and innovation agenda of clean aviation, where I'm currently also chairing the academic member forum, grouping all academic members of Clean Aviation.
Building your department's European network and contributing to initiatives like Clean Aviation and EASN Association really shows your imprint in aerospace research. At Stuttgart, your research covered some very exciting areas of innovation. Could you share with us what the main focus is right now in general and more specifically within the Concerto project?
All our research in Stuttgart is about alternative propulsion, new powertrains, new powertrain components, new fuels, and it's good to exchange on these topics with competent European partners. And now for Concerto. From my time in industry, I know that we always have to have certification in mind for these technologies, and it's good to identify potential gaps in the regulations and to see how new technologies can be efficiently certified.
Your experience with projects like Concerto seems to highlight the importance of education. Please explain why involving universities and students in such a research project is so valuable.
In projects such as Concerto, in my view, it's paramount that the universities are involved, not only because there are PhD students working on a good part of the tasks, but also aerospace students with their final thesis, wrapping their mind around future innovative technologies. In my experience, very open-mindedly and finding clever approaches. And we should not forget that's the future engineers, that's our future workforce. And in involving them in such research projects, they know what it's all about from day one and have a kickstart when starting in industry.
It's of high importance to give students real experience. Greek philosopher Aristotle said, "For the things we have to learn before we can do them, we learn by doing them." Or in the original Greek, because Andreas, I know you love Greek language and culture, όσα πρέπει να μάθουμε για να τα κάνουμε, τα μαθαίνουμε κάνοντάς τα.
Aristotle is of course right in pointing out the importance of practical application in the learning process. In Germany, we would, for example, say Übung macht den Meister, or as one would say in France, c'est en forgeant qu'on devient forgeron. At a university, of course, the focus is on the theoretical foundations, so application is not in the foreground, but it is also important to give students the opportunity to apply the newly acquired knowledge with learning by doing, and that's why I think it is really important that students have the opportunity to participate in such projects, to learn how all their learned material, the foundations, how this connects to real-life problems.
Theory, of course, is valuable, but it's in practice where really learning happens. Let's now take a closer look at Concerto, which tackles some very, very ambitious topics. Could you tell us which of these areas you see as the most challenging, and particularly from a certification perspective?
Concerto is addressing three quite challenging topics, one being the high aspect ratio wing with active flutter control, then the high voltage electric distribution and the hydrogen systems. And all these three topics are definitely challenging. So difficult to say which one is the biggest certification challenge, but personally, as I have lost an aircraft in flight testing due to flutter, I think the active flutter control is really a very important part to get aircraft lighter, but that is, in my view, for certification, the biggest challenge we address in Concerto.
And if you could sum up a single lesson from Concerto, let's say, that will influence your future work, what would it be?
A key takeaway from Concerto, in my view, is that whenever you deal with new technologies, you have to take the authorities on board as soon as possible. So Concerto managed to involve EASA from day one, and it is really very straightforward to identify gaps, to discuss the gaps with the authority, and to offer a solution how to certify a radically new technology.
That's a very interesting perspective. On contrast, I want to know the key lesson you try to teach your students.
The essence of concerto in one sentence, that's a good one. I mean, what I try to teach my students is that aircraft have not 3 but 4 dimensions, which is length, span, height, and politics. So that's what my students already would know. With the concerto experience, I would extend this to 5 dimensions. So we have length, span, height, politics, and certification. And only if you master all 5 of them, then you will have a successful product.
I like you put it beyond the science and engineering. Of course, designing an aircraft is a big part of the story, but as we understand, there is so much more involved. And now for our last question before we finish. If you could travel anywhere in time, where would you go, what would you say, and what would you do?
Where in time would I travel to see the impact of concerto? Good question. I mean, it would be good to travel to 2050 to see the new generation of climate neutral aircraft on the tarmac, and then to talk to the aircraft manufacturers how they could profit from clean aviation, from the Concerto project, from this dialogue that has been established with the authority on certification gaps, on innovative technologies. And I'm almost convinced that this would be quite a fruitful discussion, and that I would talk with happy airframers. That would be good to see, and most likely that's where I would travel. Thank you.
You know, Andreas, most people choose to go back in time to meet a great figure, but you have taken an even bolder approach, choosing to travel into the future to see the impact of your work. It really shows confidence and certainty in the success of what you are doing now. I will hold on to that, Andreas, and I truly wish the same for myself and for our listeners, that we can all move forward with the same confidence in the value of what we are doing today. Thank you so much, Andreas, for sharing this great path and visions with us today. Thank you as well, our audience, for staying with us in this episode. And remember, learning never ends, whether on the ground or in the sky.